Versatile nature of a carbon. We have seen that the formation of a covalent bond by sharing an electron in various element and compound, okay, which we have already studied in a previous lecture. That what? Okay, there is a formation of covalent bond by a worm, by whom? Okay, by carbon with other element. Okay, which we have already studied. That covalent bond will be formed by a carbon by which way? Okay, by sharing a electron in various element and compound. By sharing a electron, element will form covalent bond. Okay, covalent bond will be formed, which we have already studied in previous chapter. Okay, now what? Okay, we have also seen that the structure of a simple carbon compound, for example methane, okay, in that also we can see that covalent bond is formed. Okay, same way in the beginning of a chapter we saw how many things we use contain carbon. Okay, many of the thing which we are using contain what? Okay, carbon. Okay, in everything or most of a majority thing contain carbon. Okay, in fact we also see that ourselves are made up of what? Okay, carbon compound. Okay, in us also carbon is present. The number of carbon compound whose formula are known as a chemist was recently established to be in a million. Okay, number of formula are found, okay, by through which a carbon can be present in it. Okay, so this outnumbered by a large margin the compound formed by all the other elements put together. Number of formula are formed, okay, of a compound, okay, in which why is it that this property is seen in carbon and no other element? Okay, here you can see that carbon which are present in everything. Okay, most probably any compound are there, in that also carbon are present. Okay, why? Carbon is the only element which are present in everything because it have a versatile nature. Versatile nature means what? Okay, that are present in everything. Okay, which we said is a versatile nature. Okay, the nature of covalent bond enable carbon to form a large number of compound. Okay, carbon will form many compound. Okay, by forming covalent bond. Okay, carbon will attach with all the element, most probably majority of element get attached with a carbon by with, okay, covalent bond, and it will form a compound. Okay, once again I am repeating what? Okay, carbon have a nature of making covalent bond with majority of a element. Majority of a element get attached with a carbon by which bond? Okay, by covalent bond. Okay, so this nature, okay, are said to be versatile nature, which we said is a versatile nature because carbon will attach with majority of a element and it will form what? Okay, it will form compound. Okay, so two fact notice in the case of carbon. Okay, so just now we can see that carbon will form majority of bond, okay, with a element. Carbon has the unique ability to form bond with other atom of a carbon. Okay, ability to form a bond with the other atom of a carbon, giving a rise to the large number. Okay, what? So carbon will form bond with another carbon and it will form what? Okay, large molecule will be formed. Okay, if we have taken two carbon, okay, then two atom of a carbon will form a compound. Okay, same way, this way by connection of a carbon carbon bond, okay, it will form a large molecule and this property is called what? Okay, catenation. Okay, and this compound may have a long chain of carbon. Here you can see that. Okay, branch chain of a carbon or even a carbon atom arranged in a ring form. It can be attached with the branch chain also and by a ring form also. In addition, carbon atom may be linked by a single bond also as well as double bond also and triple bond. Okay, it will form by a single, double and triple bond also. Compound of a carbon which are linked by only single bond, okay, between the carbon atom are called saturated compound, and compound of a carbon having double bond or triple bond between them are called unsaturated compound. Okay, once again I am repeating, compound of a carbon which are linked by the single bond. Okay, here you can see that carbon and carbon. Okay, single bond is there between two carbon. Okay, are said to be what? Are said to be saturated. Okay, whereas what? Okay, compound of a carbon having double bond or triple bond, C double bond C or C triple bond C, okay, are said to be what? Okay, are said to be unsaturated. What? Unsaturated. Okay, here you can see that carbon and another carbon contain double bond. Here it is triple bond. So we say it as unsaturated, and here single bond is there. So it is saturated. Okay. So saturated compound are those in which carbon have a single bond between them, and unsaturated compound are those in which carbon having what? Okay, double and triple bond. Okay, no other element exhibit the property of catenation to the extent seen in a carbon compound. Okay, except carbon, or no other element will have property of catenation, okay, which a carbon have. So silicon form compound with the hydrogen which have a chain of up to 7 or 8 atoms, but these compounds are very reactive. Okay, so same way the carbon bond is very strong and hence stable. This gives us the large number of compounds with many carbon atoms linked to each other. Okay, what will be seen? That carbon will form a big chain, okay, and they will form a large number of compound. Okay, compound will be formed by forming a bond between them, okay, and attaching a different element, okay, in it. Okay, and it will form a huge compound. Okay, so carbon bond will be formed, and in that you can see that carbon have how much? Okay, 4 valency. Okay, 4 valency. So with a carbon many element will attach and will form a different compound. Okay, now the second is, since the carbon has a valency of 4, just now we have discussed what? Okay, carbon have a valency 4, it is capable of bonding with the 4 other atom of a carbon or atom of some other monovalent element. Okay, so carbon have what? Okay, valency 4. In that you can see that 4 valency is there. So in 4 valency we can see that any of the element can be attached which have what? Okay, monovalency. Okay, compound of a carbon are formed with the oxygen, hydrogen, nitrogen, sulfur, chlorine and many other elements, giving rise to the compound with specific property which depend on the element other than the carbon present in molecule. Okay, by attaching a different element in this 4 valency we can see that different compound will be formed which have a different property, okay, or chemical property of all the compound will be different from each other. Why? Because in that, okay, element are attached are different. For example, if we attach a chlorine, okay, it will have a different property than if we attach a hydrogen, okay, in it. Okay, so this both of them will contain different property. Okay, now again the bond that carbon form with the most other element are very strong, making this compound exceptional stable. क्या? तो okay, here you can see that carbon will form a bond with a different element, okay, and they have a different structural formula. Okay, one reason for the formation of a strong bond by the carbon is its small size. This enabled the nucleus to hold on the serrate pair of electrons strongly. Okay, what? Okay, carbon will contain a small size. Why? Okay, in that nucleus hold a serrate pair of electrons strongly. Strongly, a nucleus which are present of a carbon, they will share what? Okay, pair of electrons which are present. And the bond formed by the element having bigger atom are much weaker. Okay, bond which is formed by the bigger atom will have what? Okay, weaker. Okay, because if the atom is bigger, at that time you can see that bond will be weaker. Okay, so saturated and unsaturated carbon compound. Okay, what is saturated and what is unsaturated carbon compound? Okay, that we will study. Saturated and unsaturated carbon compound, you are familiar with that. Okay, in a previous slide only we have discussed that what is saturated compound and what is unsaturated compound. Okay, then also one we will discuss it. Okay, we have already seen that the structure of methane. Okay, structure of methane. Okay, here you can see that this is the structure of ethane. What? Structure of ethane. Okay, we have already seen the structure of methane. Another compound formed between carbon and hydrogen is ethane. Okay, this is the structure of ethane. Okay, second is we are talking about ethane. Okay, in order to arrive at the structure of simple carbon compound, the first step is to link the carbon atom together with a single bond. Okay, here you can see that first we have, okay, bonded both carbon with each other by a single bond. Which bond? By a single bond. Okay, and then use the hydrogen atom to satisfy the remaining valency of a carbon. Okay, here you can see that two carbon are there. Okay, they are attached with each other by single bond, and we are familiar that what carbon contain four valency. How many? Four. So here you can see that one valency is already set. Okay, so next three are present. Okay, in place of that three we will attach hydrogen. So here you can see that structure will be formed like this way. Okay, hydrogen, 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 and another three hydrogen. Okay, so ethane will be formed. Here you can see that ethane will be formed. Okay, in that ethane you can see that only single bond are seen. Only single bond is there between two elements. Okay, between two carbon also, and between carbon and hydrogen also there is only a single bond. Okay, so if a compound contain only single bond in whole compound, okay, in whole compound you can see that only single bond are present. Okay, then such compound are said to be what? Okay, saturated compound. Okay, which we said is a saturated compound. Once again I am repeating, if in a whole compound there is only presence of single bond, then a such compound are said to be what? Okay, saturated compound. In whole compound you can see that only single bond are seen and present. Okay, so we say it as a single bond containing compound which have a saturated compound, which we say it as a saturated compound. Okay, so from this we can say that in a saturated compound there will be presence of only single bond between two elements. Okay, and three valency of each of them are, okay, just now we have discussed. Okay, once again I am repeating. Okay, two carbon are there. Okay, both of carbon are attached with a single bond. Okay, now you can see that in carbon one valency is set, but carbon contain four valency. How many valency? Four valency there. Okay, so one is already set, so next three, okay, are set by hydrogen. Okay, so it will form a ethane. Okay, and in this compound you can see only single bond are there, so we say it as saturated carbon compound. Okay, now can you draw the structure of propane which has the molecule form C3H8 in a simple manner? You will see that the valency of all the atoms are satisfied by the single bond, okay, between them. Such carbon compound are called saturated compound. Okay, now if we talk about what? Okay, propane, in which you can see that three carbon are there. Okay, so 1 2 3. Okay, once again I am repeating, can you draw a structure of propane? Okay, so propane, in propane you can see that how many carbon are there? Okay, three carbon are there, so we have already written 1 2 and 3. Three carbon are there. This carbon, okay, this carbon, okay, has set its one valency with another carbon, so it will have only three vacant bond. Okay, three valency are left. In that three we will attach hydrogen. Okay, now in middle one you can see that 1 and 2. Okay, two bond are already set, so only two are there. In that two we have, okay, now in this carbon you can see that one is set. Okay, three are left. In that three we will, okay, write a hydrogen and it will be set. Okay, so here you can see that how many hydrogen are there? 1 2 3 4 5 6 7 8. So C3H8, structural formula of propane or molecular formula of propane. Okay, C3H8. Okay, so it is already set. And it is said to be saturated compound because single bond between them are there. However, another compound of a carbon and hydrogen has the formula C2H4 and it is said to be ethene. How can this molecule be depicted? We follow the same stepwise approach as above. Okay, carbon carbon atom linked together with a single bond. Okay, here you can see that carbon carbon linked together with a single bond. Okay, in the next step you can see that we see that one valency per carbon atom remain unsatisfied. This can be satisfied only if there is a double bond between the two carbon. Okay, now 1 2. Okay, we have taken two carbon. Okay, and we have attached two hydrogen between them. Okay, so here you can see that two hydrogen is there. Okay, between them. Okay, so carbon contain how many? 4 valency, but here you can see that only 1, 2 and 3 are there. Okay, same way this carbon also contain 4 valency because all the carbon contain 4 valency, but here in this also you can see that only 1, 2 and 3 are there. Okay, so satisfying its 4 valency, we need to do a double bond between two carbon. So it will be how much? Okay, both the valency of carbon, both the carbon valency will be set and the structure will be formed. Okay, which we said as a ethane. What? Ethene. Okay, ethene. Okay, in which you can see that double bond are present. So such compound are said to be unsaturated compound. What? Unsaturated compound. Unsaturated compound. Okay, as you can see, the electron row structure of a ethene is given in figure. Yet another compound of hydrogen and carbon has the formula C2H2 and called ethyne. Ethyne. Can you draw the electron row structure of ethyne? How many bonds are necessary between the two carbon atoms in order to satisfy their valency? Such compound of a carbon having double or triple bond of a carbon atom, okay, having double or triple bond between the carbon atom are said to be unsaturated carbon atom, and they are more reactive than the saturated carbon compound. Okay, unsaturated carbon compound will what? Okay, it will be more saturated as compared to saturated carbon compound. Now the next is what? Okay, C2H2. Okay, C2H2. Okay, okay, yeah. Okay, now we will draw the structure of ethyne. Okay, C bond C. Okay, and two hydrogen are there. One hydrogen is at here and one another hydrogen is at here. Okay, as you can see that carbon 2 valency is already set. So this carbon, okay, need how many? Okay, 2 valency, 1 and 2, and same way this also contain 3. So you can see that 1, 2 and 3 carbon and 4. Okay, 4 valency of this carbon is set and 4 valency of this carbon is also set. Okay, so the structure of ethyne will be C triple bond C H H. Okay, which we say it as a C2H2 and ethyne. Okay, so this was the structure of ethyne. Okay,
family is that of alkenes. These are the ones having at least one double bond between the carbon atoms. Now, is there a formula to represent these as well? Yes, just like alkanes, even alkenes are represented with a formula. It is CnH2n. Here as well, N stands for the number of carbon atoms. Thus, the number of hydrogen atoms in an alkene will be double the number of carbon atoms in it. That's right. For example, the simplest alkene known to us is the ethene. It has 2 carbon atoms and they share a double covalent bond. So the value of N is 2. So what will be the number of hydrogen atoms in ethene? Based on the formula, it is 2 times N. As N is 2, we get the number of hydrogen atoms in ethene as 4. That gives us the chemical formula for ethene as C2H4. Similar to ethene, all the other alkenes can be represented using this simple formula. Now we are left with the last family that consists of members with at least one triple covalent bond between the carbon atoms. These are referred to as the alkynes. We know the formulae for alkanes and alkenes now. And can you guess what could the formula for alkynes be? It is CnH2n minus 2. There's one thing we can surely tell by looking at the formulae. It tells us that for the same number of carbon atoms, alkynes will have lesser number of hydrogen atoms as compared to alkanes and alkenes. Now let us take an example to understand the working of this formula as well. We consider the simplest alkyne, that is ethyne, as our example. It has two carbon atoms that share a triple covalent bond. As it has two carbon atoms, the value of N in the formula will be 2. And the number of hydrogen atoms will be 2 times 2 minus 2. It gives us the answer as 2. 2 hydrogen atoms. Thus the formula for ethyne is C2H2.